All right, it's time. Before we move on, any questions regarding the homework, exams, and anything or quizzes? Aaron.
2.7 number 3, and then 2.8 number 4.
Seven. Number 3. Oh. Okay. Yep. Let's see. This is found in the tangent line of y equals 6x plus 1, x plus 5 at 2, whatever that is. Okay, yep. So we're looking for the tangent line. For the tangent line, we need two things: a point, which we already have, and the slope, which we now know because it's the tangent line. We need to find the derivative at 2. The rest is try to find the derivative, and for now, we don't have anything better other than the definition. So that's it. The rest will be putting everything in order. 2 plus h. X plus 5. All right. And so far, it should be just writing the definition down. The rest will be just do the algebra. Be patient. This is going to be a little bit long, but not too much. Is 7 plus h times 7. Then 7 times 12 plus 6h plus 1 minus 7 plus h times 13. Okay, this is actually 13 because we have 12 plus 1. Now limit h goes to 0. Okay. Times 1 over h. Everything I just did here is the top. Okay. And then 91 plus 42h minus 91 minus 13h. 7 times 7 plus h. Times 1 over h. Cancel. Okay. 29h times 1 over h. They cancel. So finally, it's 29 over, let h goes to 0. 7 times 7, 49. That will be the slope. And then this will be the tangent line. Adam? Adam, do you have a question?
Oh, yeah. Can you hear me?
Yep.
Yeah. Could you go over 2.7, problem 7?
Okay, hold on. Let's finish this one first.
Okay.
Let me, just in case I forget, just ask me again. Okay.
Okay.
I think I can remember, but I'm getting old. So, yep. Aaron, are we good? Awesome. Okay, so that's number 3. Now 2.8. Number 4. And 2.8, number 4. Find the formula of the derivative of this using difference quotient. Da, 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 da. Okay. So basically we're finding the derivative of gx equal. So this is another classic doing the derivative things. Go by definition. This time we want the derivative. So instead of point, put x there. The rest is algebra. Okay, cancel, cancel. Now when you let h goes to 0, this is just 10x. Sounds good? Now you see the problem. We did all the trouble just to find the derivative of this. Now remember, it's a piece of cake. It's 5 times 2x minus 0, which is 10x. You see the power of using a formula, which is basically doing the same thing for once and then memorize it. Okay, good. Now atom 2.3, no, 2.7. Number 7, if I am correct. Okay. I see. Okay. Okay, find f prime a of f prime a, definition. No prime. All right. The rest is just going to be algebra. It's a time to test your skill. Number 1, fractions, common denominator. Simplified even more. This is 1 minus a minus h, 1 minus a. Both has a 7, so I factor the 7 out. And keep in mind, everything here is just the top. So there is one more h we put in here. All right. Now you need to ask yourself, what case do you have? 2.3, 2.4, 2.5, and you realize this is conjugate. That's the only way. Now let's try to simplify. By copying everything and focus on just this part. For that gives you the square of both. Okay, that is going to be -1 plus a plus h. If you distribute the negative sign, that cancel this, which give you 7h on the top, and h cancel each other. Seven, whatever junk on the bottom. Okay. Now, good news. Good news is you can let h goes to 0 now because there's nothing stopping you from doing that now. So this is going to be square root of 1 minus a times square root of 1 minus a times square root of 1 minus a plus square root of 1 minus a, which is 7. Okay. Times 2 square root of 1 minus a, which is 7 over 2, square root of 1 minus a cube, which is that's the answer. So, definition, common denominator, conjugates. The rest is algebra. Cool. It's terrible. So much trouble just to go over this. Now, if you think about it, well, the original thing was this. You're basically asking, what's the derivative of this, right? Number one, there should be a 7 because it really doesn't matter. Number two, there should be a 1 minus x to the 1/2 negative prime. I don't know the derivative of that. I do know if it's this. Then I know it's negative 1/2, right? Negative 1/2, x to the negative 3/2. Do you observe a 7? Okay, you observe a 2. And you observe a 3/2. Actually, negative 3/2 because negative 3/2 means 3/2 on the bottom. Good so far? So you can see it's really easy once we have the rules to get the derivative of this from the derivative of this, which is just the power rule. And from here, you can see this is nothing but a composition of fx and the gx equals 1 minus x. And what you see here is actually f circle gx, which is putting 1 minus x into this. Okay, so once you know how to do this, which we already know, and once you know one differential rule, which is how to do the circle. We did plus and minus, remember? We're doing multiplication and dividing right now. And once we finish this, we will be able to handle this one in no time, which is way better than the whole thing I wrote here. That's the point of going over I think it's 3.4, the chain rule. Okay. By the way, this is just a preview. The chain rule will help you handle this, so you don't have to go over the difference quotient again. Anton?
Just to clarify, for the answer to that question earlier, was that exponent supposed to be 3/2 or 1/3?
I think, is it fair for me to say your confusion happens from here to here?
Yes.
All right. Hmm? 3/2 or 1/3? What we have is this. Do you agree?
Yes.
Now,
Oh yeah, no, sorry. I see it now. Never mind.
okay, 1
I
half
was
and
wrong.
then 3, right?
My bad.
1/3 is going to be this.
Yes, of course.
Cool. Good, good. All right. Any other questions from homework? Great. Let's finish. Product rule and quotient rule. We were at product. The key is, number one, this is wrong. No matter how much you want to do it, don't do it. Okay, wrong. Instead, a complicated formula. All right. Second, we kind of went over the intuition. Why the formula look like this? It's so weird. Or is it? Well, we kind of did this. If this is F, this is G, this is F times G. Now what you're asking is how much the whole area is changed if I change my length of both a little bit by dg and the df. Good so far? Then what we say, hey, the whole change is actually the whole increment of this band, which can be decomposed into 3 parts. Then the first part, you clearly see dg, but you clearly see f as the width. The second part, you clearly see df, and also the original size of g. There is a third part, we say too small. So when we let df and dg goes to 0, this part really just got squeezed into nothing compared to the other 2 part. Now do you observe this is basically where the fg prime come from, and this is where the gf prime come from. Okay, and the original size does matter from this graph. Of course, to give a proof, we need to be careful. This is just roughly, it makes sense. It's not a proof. Okay. And for proof, we have nothing better other than the definition. So what's the derivative? It's this. Good so far? Now I want to solve this. I want to solve it. I wish I could combine the g, and then I have x plus h minus fx. That's going to be beautiful, divided by h, which means I combine these 2 terms. And certainly after that, I have f prime g. Make sense so far? Okay, good. What's stopping you from doing that? The part stopping you from doing that is this term and this term are not the same. If they're the same, I can factor them out. Make sense here? Or in another word, I wish this one is gx plus h. Or I wish this one is gx. So I can pull them out. I can pull the f out. Still okay? Good. How do you solve that? Well, we just make our dream happen. Let's just force this one to be gx plus h. By just doing it. Okay. Of course, that's forbidden. You change the original problem. Okay. Then get rid of the term you just added. So you minus the term, you plus the term. It's equal to not doing anything. Okay. Meanwhile, keep the original term there. It has to be there, otherwise you change something. These two are the original two terms. These two are the two artificial terms I created by myself. By the way, they are the same, different sign, so it's equal to not doing them. I just chose to do them. Okay. But after that, I have a really nice format for both parts. Let's look at the part one, which is the first half, which divide from here. Now you can see the first half has this one in common. Therefore, I can take this out. The whole thing divided by h. Good so far? The trade-off is I create a redundant term here, but then if I look at it, it's not too bad either. Why? Because this one and the last one has one term in common, that is fx. So I can also pull them out. What's left? What's left is gx plus h minus gx. By adding and subtracting the same term, I didn't change a thing. Meanwhile, I changed the looking of the whole thing. Good so far? Now take a look what happened. Well, this part alone, when you let h goes to 0, this is f prime. This is g prime. Right? Then what is the whole thing? That is just g x plus h, but h goes to 0, therefore it's just gx times f prime plus fx times g prime. This is a perfect proof. The only thing we used was algebra and the definition of derivatives, which is limit h goes to 0, blah, 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 blah. Nothing else. All right, this is just to show you how to do a rigorous proof strictly from definition, so you can trust it. Okay, you don't have to know how to do it. We just go over it for once. Our major focus, of course, is how to apply this formula to solve problems. And this is the trick, which is adding the same thing and minus the same thing twice, but somehow you create the format you want. Okay, this is going to be a common trick we will see again, and again. Everything makes sense so far? We trust the formula now. Let's do some examples. Okay, example. Find the derivative of e to the x times x cubed minus 2x plus square root of x. I do know the derivative of this. I do know the derivative of this. And it's a product. Again, don't just do each and multiply them together. Instead, follow this, which is e to the x prime, keep this, plus the prime of the second. E to the x prime is just e to the x. Keep everything here. Do each. Finally, combine. And there's no more way we can simplify anything, so let's just keep this as the answer. All right. That's just how we do products. There's nothing difficult except for you need to memorize this formula. Once you know the formula, it's really just algebra. By the way, in the exam, you can have your own formula sheet for review purpose, but in the exam, you should not be allowed to use anything from the notes, from the textbook, or formula sheet or anything, which means you have to recite all these formulas. Okay? This is required by the class. And don't try to think it's dumb to memorize things when you can look it up. Just think about this. If you go to the hospital and you ask the doctor, hey, I got a pain in my chest. And the doctor say, hey, wait a second. I know how to do it. Let me just Google it. Okay, or let me just look at it in my textbook. It's in my notes somewhere. You know, I just didn't memorize it. I just need to look it up. How much do you trust that doctor? And everything he said was reasonable, right? It's just in the thing. Why do you memorize it? The problem here is you need to memorize hundreds of things in your mind, not on the textbook, in order to have a higher level of understanding. Okay, so even if you think memorizing is a pain in the butt, do it. Trust me, it's helpful. Okay, good. Let's do the quotient. F divided by G. How do you do that? Well, there is nothing better. We have already done this before. Let's check the definition. Okay, you were talking about all right. Now we want to do some algebra. And keep in mind our final goal. Our final goal was trying to associate this one with f prime and g prime alone, right? That means we're looking for fx plus h minus fx divided by h and vice versa for g. So whatever algebra you do here, you have to be focusing on the format you're looking for. Gx minus fx times gx plus h. Gx plus h, gx, that's the top. Then the whole thing divided by h. All right. The first thing I'm going to do is I'm going to switch these two because you're on the bottom. Divided by 2, then 3. Divided by 3, then 2 are the same. It really doesn't matter which one you do first. So let's keep this part at the first. The second part is the key part. That is divide by h, fx plus h, gx, fx, gx plus h, minus. Good so far? Oh, the trick. They don't have the same term at all. These two terms are different from these two terms. Therefore, I cannot factor anything out. But what I'm going to do is I'm going to keep one term to be the same. But then I cancel it. Just make sure I don't add anything which is not necessary. But now, what you should observe is the same trick again. First part, gx, fx plus h minus fx, h. That's the old trick. Here comes f prime. Okay. Splitting here. The second part is going to be the same. Here comes your G prime. Wait a second. G prime is gx plus h minus gx. This one is not G prime. This one is negative G prime. Because I flipped the order. I use gx minus gx plus h instead. Still okay? Now let's clean things up. First part give you 1 over gx when you let h goes to 0. The second part give you g times f prime. The third part gives you plus f times g prime with a negative. Now, if we clean everything up, it will look like this. That's it. That's the quotient rule. It looks weird, but we followed the difference quotient. We should trust it. Quotient rule. Sounds good. Similar trick as before. Again, we don't require you to do the proof. We just let you see it and see how we do stuff. But the key here is you need to memorize this formula. How do you do that? Well, me personally, I think the top is basically the product rule, right? Except you switch one of the sign to be negative. Second, the bottom is just g squared. It's pretty easy to memorize. Let's try to use it. So as I remember, that was Aaron, right? 2.73. We did a whole bunch of stuff, which is a pain in the butt. Okay. But now if we really go back and look at it, what's this? It's definitely a quotient. Okay. We say, please go ahead and try to find the derivative. This time, don't do the difference quotient. Don't do all the painful algebra we went over. And the answer is, sure. This is f divided by g. My f is this. My g is this. My f prime is 6. My g prime is 1. Know the formula. Put them in order. 6, 6x plus 1 times 1 divided by g squared, which is 6x plus 30 minus 6x minus 1. Which is 29. Okay, and you plug in 2, you got 29 over 49. That's exactly the answer we got before. But here are the advantage. Number one, it's way easier. Number two, because it's easier, we trust this number more. Before I went through 7 steps, every step I can mess up. I can plug in the wrong number, I can copy the wrong thing, I can forget about a constant. Anything can happen, right? Now, I'm really just confident, okay? There's nothing can go wrong here because it's so clean and easy. Sounds good? The key, memorize this. That's the key. Your turn. Try to find the second derivative of e to the x dy by x. Just a note, second derivative equals, you find the first derivative and then do the derivative again. So you do it for twice. Okay. Try it. Oh, question?
Yeah, I was just wondering, will we ever be asked to find the derivative without using the product or quotient rule, like on the first exam? Or
On the first exam, if I'm going to say that, I'm going to say, hey, are you asking like not product or quotient rule, but more about when should you use this definition, right?
yeah,
Like,
yeah.
okay, yeah. This is called the definition of derivative. As you can see in web work, sometimes we call this difference quotient. Okay, so unless I said in the question, that is find f prime 2 using the definition of derivative or using the difference quotient. As long as I say that, don't use any rule we have so far. As long as you don't see any restrictions, use whatever you want. And I hardly think anybody prefer this. So if I don't say anything, just use everything in chapter 3. Eventually, we will never use this anymore unless we see something new, because everything else is handled by the formula we introduced. Unless we run out of formula, that's when we go back to this. Okay, in general, we don't want to do this. In this exam, we definitely have to do things in the definition way because it covers everything from 2.8. I want to make sure everybody knows how to write this down. Be right back. That's the hint for first derivative. Adam?
Yeah, if you could scroll up to the last question, I was just kind of confused how you went from x plus 5 squared to 49.
Oh, they were looking for f2. F prime 2.
Oh, okay.
So one more step. Yep. Okay, now the second, which is basically the derivative of this again. Okay. Now the whole thing on the top is your f. Now you just need to realize to find the derivative of this, you have to do another product rule. The rest will just be simplify things. You need to square this. X e to the x, cancel, times x cubed, that's this. Common factor. And then finally they cancel. Any questions? Cool. That's how we do the rule. You basically just memorize the rule, know which is your f, which is your g, then follow it. Okay. Frankly speaking, a computer can be a way better job because they never make mistakes. And this is so rigid. So keep in mind, we are going to ask you to do this, not because we want you to do this by hand later. You can have a calculator, which is way better than you. It's more about training you to somehow think rigidly, to train you how to find your mistake, how to verify your answers, okay? It's almost like a normal people without training in calculus or mathematics. Their thoughts are like horse, a wild horse. But now what you did is just put a saddle on them and ride them, okay? So this is exactly the process we're going through to write your thoughts so they will listen to you instead of they just go randomly and you cannot capture them. Okay, so if you feel like this is, how to say, uncomfortable, that's exactly the thing you need to go through. Okay, you need to feel comfortable about clearing your thoughts if you're doing science. All right. That's it. That's the product rule and quotient rule. We can go over more examples, or, which I prefer, is we all go back, do some homework, and come back with your own examples. Okay, otherwise it's just me going over it again and again. I would rather to go over it when you have already practiced by yourself. Okay, so I'm expecting a lot of questions from your homework for all these sections because they can be hard, they can be easy, they can be weird. Okay, so if you have anything that you are hesitant, don't even worry about it. Just bring it to class. I would rather to go over 7, 8 examples if necessary. Okay, so just bring them to class. It's a good practice. All right, number 3, some side topics really quick. They're not important, meanwhile, they're kind of like a natural extension, worth mentioning. The first one is this, the one we just did. Quotient rule or product rule. Clearly, this is a quotient rule. No. Yes, okay. Good so far? Meanwhile, by algebra, we do know every time you see a dividing, you can change it to multiplication. Okay, and we do know the f prime and g prime in this case, even though we have 1 over x, we do know that. So this one is also a format of product rule. Okay, which one is correct? Both. They're all correct. So in real life or in exams, feel free to do either. Sounds good? Every time you see a quotient, you can always change it to be a product. Just times the reciprocal. Okay? They gave you the same answer. Which you should be confident. Okay. The only trouble you may have is, let's do this one. In the product rule. So the final answer for this one is going to be e to the x times 1 over x minus e to the x times 1 over x squared. Now, do you remember the answer we got from the quotient rule? It's this. Okay? From here, you can see they are not the same. But now if you think again, well, if I just simplify further, common denominator. Okay? And then you see, well, even though they don't look the same here, but actually if I start to simplify using some algebras, they will be the same. Good so far? The reason I point this out is because sometimes you use some way to find an answer. You check online and you find a different answer. Okay. And you may think, wow, since my answer is different from what I checked online, and they are correct, therefore my answer must be wrong. Sounds good? This one tells you your answer may look different, but actually they are the same answer if you did things in a different way. Okay, so when you see things like that, don't second guess yourself. Just try to see they must be the same. If I trust my calculation, I couldn't find anything wrong with my algebra, they must be the same. Okay. This is still easy to check. Imagine if I did the second derivative using product rule again, how different that thing is going to look compared to this one. It's going to be super different, and you won't be able to tell they're the same unless you do the algebra. Okay, so just be confident. In our class, I don't have a preference. Do either. As long as you get the right number, I'm going to give you the point. And just in case, sometimes in the exam, if everybody did it in the quotient rule and you did it in product rule, I may mark it wrong. The reason is because I was grading too quickly. So I didn't realize that your answer is correct. Okay, so it's up to you to check your answer and find actually it's correct, and then correct me if I mark the wrong answer and give you and didn't give you the grade you deserve. Sounds good? For easy ones, I can check really quickly. For harder ones, I would say, wow, you got a ridiculous answer, so I don't want to even bother looking at it. But then second thought, maybe they're the same. Okay? So just try to help yourself a little bit and make my life easier also. Of course, for product rule, you can stop here. You don't have to simplify everything to be look like this. Not necessary. All right. Second big thing. We know how to do this. It's a product rule. All right. But how do you do this? When you have a product and a product again. Make sense here? And maybe you can have 4, you can have 5 factors there multiplied together. How are you supposed to use product rule to solve this? Well, number 1, what you can do is you can pretend these two together is one function f, and the last one is a g. So just use the product rule again, one time, pretending these things are the product. And then for this part alone, because it's a combination, then you do the product rule again, just for this part by doing this. Sounds good? So when you see a lot of things multiplied together, what you can do is you can first assume this is my one function, this is the second function, but then later, this is actually 2 functions, so I do product rule again. You can decompose them again until you reach every single functions, where you have to apply the product rule for multiple times. Sounds good? The good news is the mathematicians have solved this for this. They don't have to do that. Instead, we do have a general product rule, which is easier than doing this again, but they reach the same answer. That is, this formula. For 3. Okay, what does it mean? That means if you have 3 functions multiplied together, your principle is do the derivative of one, keep the rest. Do the derivative of the second one, keep the rest. And do the derivative of the third one and keep the rest. So you do one derivative for one term, keep all the rest, but you let the one you take derivative to alternate it from term to term. Good so far? Quick example, what if you have 4? I'm going to use A, B, C, D, okay? I don't want to create another things. Now you know it's basically repeat this one for 4 times. And remember, each time you only take the derivative of one of them, keep all the rest. So I take the derivative of A, then derivative of B, then C, and then D. So if you have n factor, you should have n terms. And every single term, every single factor take turns to have a derivative. Okay, and keeping the rest to be the same. Okay, that's the general product rule. I think that's it. That's all for today.